Hey there, it's Alana Tucky, and I'm back for some more statistics video tutorials. So I'm working in chapter 11 right now, and I wanted to show you guys how to use the calculator to help you with the inference for two means dependent samples. And these are my notes. Now remember, of course, these notes are available online, or you can email me. They're also available in the bookstore. And I wanted to show you one thing right here. Namely, I have these not using the cell phone and using the cell phone, and then I wanted to find the difference in this column right here. And you can see that what I've done is I've taken this column value 636 and subtracted away 604. Now there's a way you can get the calculator to do that work for you. So you go to Stat, choose Edit, either by pressing number 1 or Enter. And you can see I've typed in the data right here. So I have L1 right here and L2 right here. And what you can do is you can go up into L3. So you make L3 dark. It's called highlighting it. And you can say, I want L3 to be second L2, take away, second L1, enter. And then it found all the values for you. See right there? So it finds every difference that you were looking for in the table. So 32 is the first one. The next one is 67, and so on. And the next one is 75. Beautiful, isn't it? Does all the heavy lifting. All right, now let me remind you that you can also use the calculator to do this lovely box plot over here. So let me go to stat plot, which is above my y equals. And I've already done it, so bear with me here. But you go to number 1, and you go down, right, and turn on this box plot by pressing enter, and make it so that it's L1, which was the, I think, non-cell users. Then you go back to stat plot, you pick number 2, which is plot 2, you turn it on, and then you go down here, right, oops, left, there we go, and you turn it on by pressing enter so it's dark. Then you go zoom, choose number 9, which is zoom stat, and there you have the box plot side by side. I mean, it's not as pretty as the one here in the notes because this was made with Minitab, but it's still quite lovely. All right, then we get down here to our null and alternative hypothesis and testing that null and alternative hypothesis. So they want to see whether there is this difference in between cell phone and non-cell phone time. So let me type up the null and alternative for a second. Hold on. Here we go. Now they just say, is there a difference? So I'm going to make this a not equal to problem right here. All right. Now there's all sorts of steps and all of that, and I'm not going to get into every bit of it here, other than to say, whoopsie, step 1 is right here. Step 2 is right here. It's the alpha is equal to 0.05. All right, I guess I am going to get into all of them. Hold on, I'll be right back. Okay, there it is. Now you can see we need the t-statistic, but it mentions right here in this instruction sheet how to do this. You go to Stat, you go to Tests, which is to the right, you pick number 2, t-test. Now we have data to work from here, so I'm going to choose data. What's my hypothesized difference? The answer is 0, because if you go to the null hypothesis, if they were truly equal to each other, here, hold on. If they were truly equal to each other, then the difference of them would be 0. Okay? All right, where's my data? My data is in L3 because that's where those differences were. Right? If you typed them in L1, then put L1. But whichever column has your differences, that's what you type in. And this was a not equal to. This was a two-tailed test. So I go down to calculate. And I can see there's my test statistic. It's 5.44. Oh, hold on. There we go. 5.44796 is my test statistic. And I can see that my p-value is 0.000050, then a 594. Notice that that's scientific notation, my friends. That's 5.94 e negative 6. Remember, it's a probability value that you're finding with p-value, so there's no way it's ever going to be bigger than 1. Right? It's scientific notation. And just for the record, you would totally reject the null hypothesis because your p-value is less than alpha. All right, that's that problem.